Hey, Math 20-2. Today we're going to look at multiplying radicals. So before we do that, let's do a quick review of multiplying algebraic expressions. So we're going to use the distributive law to expand the following. 4 times x plus 8. Recall that every number inside the bracket will go multiplied by the number outside. So 4 times x is 4x, and 4 times 8, 4 times a positive 8 is a positive 32. Same thing in part B. Using the distributive rule, we're going to distribute the first term, negative 2x, make sure it gets multiplied to every term inside the brackets. So negative 2x times a positive 3x and negative 6x squared. And negative 2x times a negative 5 is a positive 10x. Same thing can also be true for multiplying two binomials. We could use the acronym FOIL to remind us how to do this. Or we can just make sure that every term in the first bracket gets multiplied to every term in the second bracket. So x times 2x is 2x squared, and x times 1 is x, and 6 times 2x is 12x, and 6 times 1 is a positive 6. And now we're done multiplying. Now we're going to collect like terms. The 2x and 12x are the same, so we can add those two together. Sorry, the 1x and the 12x are the same. So 1x plus 12x is a positive 13x. And those are the only two terms that are like, so we can only combine the two like x terms. And if we look at this example B, we're multiplying the number 5 by two binomials. I would suggest we do the binomial multiplication first. Let's keep the 5 out front and make sure every term in the first bracket is multiplied to every term in the second bracket. So 2x times 4x is 8x squared, and 2x times 7 is a positive 14x, and negative 3 times 4x is a minus 12x, and negative 3 times a positive 7 is a minus 21. So we keep that in brackets. I'm now going to simplify inside those brackets by combining like terms. So there are no other x squared terms, but there is this positive 14x minus 12x, which are like. So 14 minus 12 is a positive 2x, and you keep the minus 21. And now we're back to the situation we had up above, where we've got a number multiplied by a polynomial. So make sure that number 5 gets multiplied to every term in the brackets. So 5 times 8x squared is 40x squared, and 5 times 2x is 10x, and 5 times a negative 21 is a minus 105. So we've finished multiplying all those situations, and you should have done that in grade 10, which we did. So that's a review. Let's investigate multiplication properties of radicals. So use a calculator to determine whether the following statements are true or false. So away you go. I want you to use your calculators and decide whether these are true or false. So pause this video, see what you come up with, and then restart it. So what we should have found out is that A is true, B is also true, C you should have found out is true, D was false, E was true, and F was true. So based on the results from A through F, write a rule which describes the process of multiplying radicals. So the rule, I would say, radicals with the same index number may be multiplied together. You're going to multiply all the coefficients together, you're going to multiply all the radicands together, and you're going to keep the same index number. So only the radicals with the same index number can be multiplied together. We multiply the coefficients, we multiply the radicands, and we keep that index number. All right? Great. Multiplying radicals then. To multiply radicals, the index must have the same number in each radical, so we must have the same index numbers. Multiply the coefficients, multiply the radicands, keep that index number, and at the very end, see if you can simplify the radical. if possible. All right. So example 1. Multiply and simplify where possible. So these are both index numbers of 2 square roots. So we multiply the coefficients. 1 times 1 is still 1. Keep the same index number and multiply the radicands. 5 times 2 is 10. So we end up with radical 10. We can simplify radical 10, so that's as far as we can go. Radical 6 times radical 6. Keep our radical sign, and 6 times 6 is 36. Well, we know the second root of 36, the square root of 36 is 6, so we simplify when we're done multiplying. Part C, multiply the coefficients. 2 times 4 is 8. Root 5 times root 6 is root 30. Look at radical 30, see if you can simplify it. We cannot, so we're done. Moving on to D. Multiply the coefficients. Negative 5 times 3 is a negative 15. Radical 3 times radical 3 is a radical 9. So we can simplify radical 9, or square root 9. The square root of 9 is 3. So negative 15 times 3 is a negative 45. All right. Part E. 4 root 5 all squared. What that means is we take 4 and we square it, or 4 times 4, which is 16. We take radical 5 and we square it. Radical 5 times radical 5 is radical 25. And now I simplify it. 16 times the square root of 25 is 5. So 16 times 5 is 80. All right. And F. Negative 7 root 3 times negative 7 root 7. We can multiply the negative 7 by negative 7. We get positive 49. Radical 3 times radical 7. We keep the radical, and 3 times 7 is 21. Look at radical 21, see if we can simplify. We cannot, so we are finished that question. Example 2, now we've got a few variables thrown in. Determine the following products. Radical x times radical x. Well, if you do that, we get the square root of x squared. Well, the square root of x squared is x. All right. If we do part B, take the numeric coefficients. 8 times 9 is 72. We go radical 8 times radical a is radical a squared. Well, the square root of a squared is a, so we've got 72a. And finally, 2 radical x times 5 radical y. We take the coefficients. 2 times 5 is 10. Radical x times radical y. We can multiply the radicands. We get radical xy. All right. Michaela and Richard are determining the radical product. 2 radical 8 times 5 radical 12. Michaela multiplies the coefficients and multiplies the radicands, and then converts the answer into simplest mixed radical form. Show her method below. So she's going to multiply the coefficients. 2 times 5 is 10. She's going to multiply the radicands. 8 times 12 is 96. She is now going to simplify radical 96. So that's like saying 10 times the square root of 2 radicals. Look for a factor of 96. That's a perfect square. I think if you go 16 times 6, you get 96. So we could now simplify this. This is like saying 10 times the square root of 16 is 4. There is no square root of 6. So radical 96 becomes 4 radical 6 in simplest form. And then you multiply that by 10. So 10 times 4 is 40 radical 6. So there's Michaela's method. Richard converts each radical in the original step. Richard converts each radical into simplest mixed radical form, and then determines the product. Show his method. So he says 2 root 8 is the same as saying 2 radical 4 times radical 2. So he simplifies radical 8. Then he's going to multiply that by 5 times, instead of radical 12, that's radical 4 times radical 3. So he's going to simplify those radicals first. So he's got 2 times, the square root of 4 is 2. There is no square root of 2, so you keep that as 2 radical 2. That's the same as radical 8. And Richard's multiplying that by 5 times. The square root of 4 is 2. And there is no square root of 3, so you keep that as radical 3. And now Richard would simplify here by going 2 times 2, which is 4, and you keep the radical 2. And you go 5 times 2, which is 10, and you keep the radical 3. Then the last step he would do now to simplify these radicals, he would take the 4 times the 10, which is 40, and root 2 times root 3 is root 6. So it doesn't matter which method you're doing, they both work. It's usually easier to convert each radical to simplest mixed radical form, like Richard did, before you multiply, especially if the radicals are really large. If we had a really large radicand here after multiplying, it makes it really difficult to simplify. But simplifying radical 8 and radical 12 is not that difficult. So I would strongly suggest we use Richard's method whenever we can. All right. Let's look at example 4. Determine the area of the rectangle. Express your answer in simplest mixed radical form. So we know the area of a rectangle is length times width. We know the length, we know the width, so I could write this as 4 root 28 multiplied by 3 root 25. Now if I go ahead and multiply these radicals without simplifying, I would go 4 times 3 and root 28 times root 25, and I get some really large numbers. However, if I do it by simplifying, first I could say the area is 4 times radical 28 can be written as radical 4 times radical 7. And 3 radical 25, well, the square root of 25 is 5, so that's 3 times 5. All right. So the area would be, simplifying this first term, 4 radical 28, that's like saying 4 times, square root of 4 is 2, there is no square root of 7. So 4 times 2 root 7, and 3 times 5 is 15. So simplifying one more time, 4 times 2 root 7 is 8 root 7. We multiply that by 15. So the area of this shape would be 8 root 7 times 15, which is 120 root 7. All right. Let's do example 5. Use the distributive law to expand and simplify where possible. So the first part of this lesson, when we remember the distributive law for polynomials, it's the same thing for radicals. We take radical 7 multiplied by radical 3. We learned how to multiply radicals, so radical 7 times radical 3 is radical 21. We then take radical 7, we multiply it by radical 2. Radical 7 times radical 2 is radical 14. Now we look at the radicals and see if we can simplify them. We can't simplify radical 21 or radical 14, so that's the correct answer. Part B, exact same thing, but now we're multiplying a radical through the brackets. So negative radical 6 times 2 radical 3. Well, negative times 2 is a minus 2. Radical 6 times radical 3 is a radical 18. We'll do the same thing with negative radical 6 and the last term. So a negative times a negative is a positive. Radical 6 times radical 2 is radical 12. So I'm done multiplying, but the question now says simplify where possible. I can simplify both radical 18 and radical 12. So let's do that. This is negative 2 times square root of 18 can be written as square root 9 times square root 2, plus radical 12 can be written as square root 4 times square root 3. I now simplify. Radical 9 is the same as 3, so negative 2 times 3 root 2, added 2, square root of 4 is 2, there's no square root of 3. And last but not least, I'm going to expand this last term. Negative 2 times 3 root 2 is a negative 6 root 2 plus 2 root 3. Now we learned last day we can't add those together because they are unlike radicands, so that's as far as we can go. And let's finish part C. Radical x times 2 radical x. Well, I take my coefficients. 1 times 2 is 2, and radical x times radical x will be radical x squared. Actually, before we move on to this one, let's just look at something here. Let's watch this. If I say radical 7 times radical 7, we've learned that's the same as saying the square root of 7 times 7, which is 49, and the square root of 49 is 7. If I said, what's the square root of 11 times the square root of 11? Well, you'd say, I keep the radical sign, I multiply 11 by 11, I get 121. And what's the square root of 121? 11. So we're seeing a pattern here. So if I said, what's the square root of 43 times the square root of 43? We should be quick enough now to say, well, the square root of 43 times the square root of 43 is simply 43. Or if I said, what's the square root of y times the square root of y? Well, we should be quick enough to know if I multiply the square root by itself, I'm going to get the radicand y. All right? That works for every single radical. All right? If you multiply a radical by itself, you're going to get the radicand. Okay, that works every time, except in this situation. If you multiply root beer by root beer, you never get beer. All right? Any other time it works. Okay. So if we go back to example C, I said 1 times 2 is 2, and now root x times root x is simply x. All right, we're multiplying a radical by itself. We get the radicand. And I multiply root x by root y. Well, 1 times 1 is still 1. Root x times root y, you keep your radical and you multiply x times y. And we're done there. So what we just learned makes that a little bit quicker. Let's look at example 6 and A and B. These are the most difficult we're going to have to do. Write an simplified expression for the area of the shape. So we got a rectangle. So the formula for a rectangle, for the area of a rectangle, is length times width. So my area is going to be length 7 minus root 6 multiplied by the width 4 plus root 6. And just like we multiplied two binomials by making sure every term in the first binomial got multiplied by every term in the second binomial, we're going to do that here with these radical binomials. So our area would equal, make sure 7 gets multiplied by both terms. 7 times 4 is 28. And then 7 times root 6, a positive 7 root 6. And then negative root 6 times 4 is a negative 4 root 6. And then negative root 6 times positive root 6. Well, a negative times a positive is a negative. Root 6 times root 6 will just give us 6. All right. Now combine like terms. So I've got 28 minus 6. 28 minus 6 is 22. And I've got 7 root 6 minus 4 root 6. 7 minus 4 is a positive 3, and you keep the radical root 6. So there is the simplified area of A. You guys try B. Pause the recording. You guys try B and see if you can get it. Then you can restart it again and see if you get the same answer as I do. All right? Okay, so here's what we should have. Area is length times width, but this is a square, so in this case we could say side squared. So my area would be the side, 2 radical 18 minus radical 27, all squared. And I would suggest step 1 would be to simplify these radicals. So 2 radical 18 and radical 27. So I'm just going to simplify it inside the square here. So instead of 2 radical 18, I can write that as 2 times square root 9 times square root 2, which is 2 times 3 root 2, which is 2 times 3, which is 6 radical 2. minus radical 27 is radical 9 times radical 3, which is minus 3 root 3. So I get 6 root 2 minus 3 root 3 instead of 2 radical 18 minus radical 27. So my area should be 6 radical 2 minus 3 radical 3 all squared. Or if you'd like, you can write that out again. 6 radical 2 minus 3 radical 3. All right. Now I'll use my distributive property like we did on the example to the left. So 6 radical 2 times 6 radical 2. Well, 6 times 6 is 36. Radical 2 times radical 2 is 2. And then we take 6 radical 6 and multiply it by negative 3 radical 3. So 6 times negative 3 is a minus 18. Radical 2 times radical 3 is radical 6. Take our second term, make sure it gets multiplied every term inside the brackets. So negative 3 times 6 is a minus 18. Radical 3 times radical 2 is a radical 6. And negative 3 root 3 times negative 3 root 3. So negative 3 times negative 3 is a positive 9. Radical 3 times radical 3 is just 3. Let's simplify what we've got here. 36 times 2 is 72. Minus 18 radical 6 minus 18 radical 6 plus 9 times 3 is 27. And now let's combine like terms. So the area should equal 72 plus 27 is 99. And negative 18 root 6 minus 18 root 6 and negative 36 root 6. Those are two like terms. So there's the area of our second square. All right. Great. So questions 1 through 16, you know which ones you should be doing. Away you go.